Hi, welcome to another set of video notes. We're going to move on to 4.3. We're going to solve x squared plus bx plus c equals 0, or in other words, a quadratic equation, by factoring. Now, you've done this before, but we're going to look at it a little differently. And if you notice, I snuck an A in, because this is really the title for your next section, but I think it's just easier to go ahead and do it all together. Okay? So we're going to notice something about our A's as we go through this set of notes, and then we'll talk about it. But here are your steps. We're going to talk a little bit about the steps before we even start practicing. First thing, this is easy. You've done this before. Find A, B, and C. Not a problem. Number two, you're going to multiply A and C together. You're going to find all the factors for that. And then you get to circle or pick the pair that adds up to B, or what that middle term is. This one sounds a little trickier. We'll talk about it. We're going to write it out in expanded form. In other words, whatever the pair was, you're going to write it out that way. We're going to group some terms together. We're going to factor out what's in common. Then we get to factor again. And then we're going to set each equal to 0 if we're asked to do that. Let's go ahead. I know those first steps are pretty self-explanatory and the others get fuzzy. I think you'll understand it more when we look at an example. So let's come over here. If you had something like this, it would probably just say, factor this expression. Okay, we can't call it an equation because it doesn't have an equal sign. So first step, find A, B, and C. You are really good at that by now. A, B, C. So what's the A here? Oh, it's 1. Maybe that's why there's something special about it. B is 14, and C is 48. Now, your next step was to take A times C, so that's 1 times 48, and that equals 48. And then you're asked to list all the factors of 48. Well, let's list some of them. There is 4 and 12. Okay. Ooh, there's also -4 and -12, correct? We've got, 6 and 8, -6 and -8. We've got 2 and 24, and we've got -2 and -24. We've got 1 and 48. We've got -1 and -48. We've got 3 and 16, or -3 and -16. So now I think we've gotten all of them. Let's see, 1, 2, 3, 4, 6, and then we jump to 8. Yep, we got all the factor pairs. So which of these, when we add them together, will give me 14? You know, and I wonder if some of you sitting out there watching this figured out 6 and 8 right away. Okay, well, if you did, great. Now, here's where we talk about the expanded form. So we're going to write x squared, but instead of writing 14x, we're going to break it up into 6 and 8. So 6x plus 8x plus 48. See? So we expanded it. That's what I'm talking about. Now, the next thing I told you was to group them. First 2, second 2. Now, what do x squared and 6x have in common? Oh, x. And you're left with, what's x squared divided by x? Just x. What's 6x divided by x? Oh, just 6. And then we come over here. What do these have in common? Oh yeah, 8. And what is 8x divided by 8? X. And what's 48 divided by 8? 6. Okay, now this should always work. You should always find something in common. That's okay, even if it's just a 1 that you pull out. Now notice, in my steps, I said the parentheses stuff should be the same. Is it? Yes. Awesome. And then I say put the factored stuff into a binomial. So we factored out x and 8, so we're going to write x plus 8. Put that together, and then just bring along the x plus 6. Oh, wow. And we factored this. Now, some of you probably remember looking at this and going, oh, it's positive. They should both be positive. 2 numbers that multiply to 48 that add to 14. Yeah, that's how we used to do it, but I'm a part of the new math revolution that says quit doing it that way, do it this way, okay? Then, if I ask you to find the zeros, which I didn't, you could set each part equal to 0 and then solve it, okay? Let's come over here. We're going to do another one, okay? This one looks pretty much like we had before. We've got the r squared and 2r and a negative 63. I'm going to get rid of this now. Okay. All right, so first step, what is it? Find ABC. What's the A here? 1. What's the B? 2. And the C is negative 63. Okay? Next step, take A times C. So that's 1 times negative 63. And now we have to list all the factors. Well, let's see. A positive 1 and a negative 63. A negative 1 and a positive 63. And if I were you, when you get one pair, go ahead and switch the signs. Let's see, what else? 2 won't go in there. Oh, 3 will. 3 and negative 21, negative 3 and positive 21. Okay, 4 won't go in, 5 won't go in, 6 won't go in. Oh, 7. 7 and negative 9 and 7. Now, since the numerals are actually close to each other, now we know we're done finding factors. So, do any of these add up to 2? Okay, well, it's either this one or this one. Oh, what did I do? Oh, I switched around. I'm sorry, guys. Let's fix this. Let's make this negative 7 and positive 9. Okay, now, so you might get, oh yeah, these are a difference of 2. But which one? Well, what is our B? Positive or negative? It's positive. So we need the 2 that give us a positive 2, which is right there. So now, oops, sorry, I'm back. Number 3, we're going to write it in that expanded form. So we've got r squared minus 7r plus 9r minus 63. What were we supposed to do? Group them. Okay. What do these two have in common? Oh, an r. So you've got r squared. Oh, you've got r and a big blurb minus 7. What do these have in common? Oh, 9. Okay. So 9r divided by 9, or take out 9 is r. Negative 63 divided by 9 is negative 7. Oh, look. Came out exactly the same again. Yes. So, what do we do in step 4? Are we on step 4? No, not really. We kind of step 5. We kind of did a couple things at once. So, 6, we're going to put that stuff that's out in front together. And then, since those are the same in both, we put it behind. And you factored it, and you're done. Awesome. Okay, now let's move on. We've got one more example. Not because it gets harder, but it gets a little trickier. So I want you to see this kind before you try any problems. Once again, got your expression? So we say A equals 1, B equals negative 9, and C equals negative 5. Make sure to include the signs. That's really important. Okay, so that was step 1. We're going to move on to step 2, and we say A times C, so that's 1 times negative 5. What does that give us? Oh yeah, negative 5. Okay, so let's come up with all the factor pairs. 1 and negative 5, or negative 5 and positive 1. Oh, what did I say? 1 and negative 5, or negative 1 and 5. Do either of those add up to negative 9? No. So then you just write cannot be factored. And you will probably have a couple of those, okay? All right, now, if in any of these problems I had set them equal to 0, or I had said find the zeros, we'll start on this one since we're right here. All you do then is at step 7. You'd set each part equal to 0, and then you'd solve. So how do I get r by itself? Subtract 9, and you get r equals negative 9. What would you do here? Add 7, and you get r equals 7. Another way they can call it are the roots. Find the roots. It just means set them each equal to 0. Okay? Last little part that we want to look at. There are a couple patterns that happen so often. We call them special factoring. And this is something you can put on your cards. Okay? Anytime you see one number and another, or one term and another term, and they're perfect squares, you can factor it like this. So for example, if you've got q squared minus 100, well, that's a perfect square, and so is 100, because remember, 10 times 10 is 100, so it's a perfect square. So you could just write this as q plus 10 and q minus 10. And if you think about it as an A, B, and C, this is the C, this is the A, and you don't have B, so you want to know what adds up to 0. Oh yeah, positive 10 and negative 10 would, so it works out fine, even if you go through all the steps, okay? The other two are very similar. You'll have a perfect squared and a perfect squared term, so like x squared or the number 25 or 49, something that's a perfect square. And then twice, these two multiply together. Now, I don't think you notice this as quickly, but here's an example, okay? So this is y squared, so just y times itself. Is there a number times itself that gives you 64? Yeah, 8. Oh, wait a minute, isn't 16 like 8 times 2? So this is one of those special ones. I'm going to come over here so you can see maybe a little easier. So I just take whatever the first term is, y, and then since it's a plus, I use the pluses, and whatever this term is, the square root of it, so 64, the square root of 64 is 8, okay? And then 8y plus 8y, yep, gives you 16. So it's just a shortcut. It's not something you have to do. You could go through and say 64 times 1 is 64. What two numbers multiply to 64 and add up to 16? Oh, plus 8 and plus 8. It will still work, okay? But it is a shortcut. So hopefully that helps, and I'll see you in class where we can practice. Bye.